Hello everyone, this is Amir from Audio Science Review. I have another product review for you. It's the Chord Hugo TT2. As you probably have seen, I've tested just about all of their other products, DACs, and people kept talking about this TT2 being special, different. So it was fortuitous that a member had one to send me for testing. It's quite expensive, $6,725 for a DAC and a headphone amplifier, so expectations are quite high as far as what performance it should produce. Chord designs are quirky, to say the least, usually with some kind of light show and these globes and everything. I found this version of it to be worst of the bunch. It's got a green dot matrix LED display in here that's hard to read, it's slanted, and it's kind of dim, and it auto shuts off all the time. These labels here, you can see them well in my picture, but if you're looking from above, they're almost impossible to see and read. You get used to them, but you know, it's just these are little things that you want to get right on this thing. Fortunately, it comes with a sort of a cheap looking, remote, but it works a lot better than trying to navigate that. Unfortunately, not everything's on the remote, so a simple thing like a menu button to push to go in there and change the gain is not in here, so you have to go back and use the box again. So overall, I'm not a fan of it, but you don't come to my reviews to hear about my opinion of the hardware itself. I've got the specs in here. You're welcome to go read it. Most of my testing is focused on XLR output and headphone output, but I also tested RCA briefly, and I'll show you that. So starting with our XLR and setting the gain to low, which gives you the best performance, and adjusting level as close as I could to 4 volts. It's kind of hard. It goes from 4.3 and then jumps down to 3 point something. So I gave it the benefit of doubt and selected 4.3 volts. We get a sum of distortion and noise as stated in sign out of 115 dB. 115 dB is a very good number. Lands well inside of our excellent bucket. But for this class of product, I expect it to be all the way towards the end there. If I zoom in the products around it, you actually see products like this SMSL balanced DAC is only $170. And so it's not a good place to be if you want to sell on performance, and the company is very keen on doing that. The XLR output on this thing puts out tons of voltage, and depending on whether you use low gain or high gain, it can go all the way up to almost 16 volts of output in high gain with very good performance, similar performance at 115 dB. So if you have a low gain power amplifier, then this would be a good pairing. It's essentially pro level output levels on this. As I mentioned, I also measured RCA, and the performance is the same. There's some people saying, look, internally single-ended is not a balanced DAC, so single-ended must be better. But again, I'm set the voltage to 2 volt as nominal for that, and sign out did not change. The issue with this DAC, if we can call it an issue, is that its noise performance is not that great. Yes, it gives you 19 bits of dynamic range in here, but state-of-the-art DACs go up to 22 bits. So it's way, way behind as far as how good DACs gotten and how silent they've gotten. And they only provide one spec of 127 dB, which is extremely good if they could get that, but it uses A weighting, which is a way to chop off a lot of the low frequency noise. But even after I did that, I only got up to 120, not 127. And they need to specify voltage or test conditions of how they got to 127, and unfortunately they do not. So, we're stuck with what's there. So we don't get the spec, and we don't get a competitive number. Intermodulation, noise and distortion reflects the non-competitive noise level. This dashed line in blue is the reference I have, is a $250 DAC and headphone amp. And look at this guy, it's the TT2 struggles to match it till it almost gets to the end, then it has less distortion. But as far as noise, which is one of the simplest things to hear, it doesn't do any better from this compared to this 2 or 3 year old very, very budget DAC. And I think noise is also responsible for this linearity not being ruler flat. Even budget DACs today at $100, $150 will nail this test with, flat response to 20 bits minus 120 dB. And this one can't do it. You can see that it's getting wiggliness, all the way throughout on this. So, sort of audibility and everything is great, but it's just competitively it's not. Distortion is very much under control and it's frequency independent as far as the noise floor at the bottom. So this is 21 bits. I think state of the art is 22 bits or a little bit more. But, I'm not going to fault this that much as the noise. Jitter performance is excellent, whether I use Toslink or USB, but the noise floor is high. This needs to be at the bottom of this graph, almost falling off the bottom. And if it did that, maybe we would see more of the spikes. But as it is, it's excellent performance, so not a big complaint. Claim to fame of Chord DACs is that they use very high tap FIR filters, and those high tap filters allow them to have a very sharp transition between what should be there, what should not be there. This vertical line in red is what the ideal DAC would be, and many DACs we see a slow slope over here that goes 2 or 3 kilohertz before it goes down. This one does it extremely fast, which is a good thing. And also the attenuation level, how much it cuts off the stuff that's out of band is very, very good. So as far as what its claim to fame is, objectively, it's accomplishing that. It has 4 different filters though, and you see them all landing on top of each other. That's because this chart doesn't have very high vertical resolution. So if we zoom way in where we're only plus or minus 2 dB and I run a different test, we can see that there are 4 filters, but 2 of them, there's only 2 different ones when it comes to audible impact. 2 of them land on top of each other with this roll off that goes as low as 3 kilohertz, but doesn't do a significant amount until you go after 10 kilohertz or so. And then 2 that have barely any roll-off at all. The manual is obscure, talks about filtering ultrasonics. I went ahead and extended the response to 96 kilohertz, and even then I barely see a difference. So as far as I'm concerned, it really has 2 filters. One of them is flat, the other one is not. I suggest using the flat one. They call this one warmer. I don't know how much warmth you get out of chopping off a little bit of 10 to 20 kilohertz. But anyway, it's there. You can play with it. That good filter always results in a good showing in this test. And we can see that the wideband noise and distortion is flat, which is excellent, and is quite low. It's not a state-of-the-art, because the state-of-the-art would be down here, but really hard to fault it on this front. So this is a very good showing. Now, in the last review of the Chord Dave that I did, a lot of people came back repeating company's argument about time domain performance. The company doesn't provide any measurements to prove anything that they're saying as far as time measurement is measurable, little audible. And people keep asking, saying, well, you didn't run an impulse response, you didn't run an impulse response. So I spent some time developing an impulse response and made a comparison with a very traditional DAC, which is this topping D70S that's sitting on my bench, and generate an impulse response. The one in blue, which happens with no delay, is essentially no delay, is the topping. We can see that the Chord DAC has a substantial 35 millisecond delay because that FIR filter needs many audio samples before and after where the signal comes out. So it has to buffer that much before it starts playing. And at high level, there's no difference between these two, as you can see. They both have a rise and a drop on the other side, and they look the same. But to be fair, we need to zoom way in and see the detail in there. So that's what I've done. First, I've magnified the heck out of the vertical scale. So this is much, much zoomed in. So we're really looking at the tails of these things, which is where the company talks about and the number of taps and everything shows up. And then the other thing I did was that I grabbed this one and I grabbed this and I lined them up inside my Photoshop program. So both the blue and the red, so the topping and the chord, are both sitting over here as far as their main impulse, and they're both trailing like this, and you can see that the blue and red are basically the same. These are the actual oscillations, and then they both blend into the noise around the same amount of time. So I see no difference in pre-echo, as this is called. It's not the correct term, but pre-ringing that's in there. There's no difference. But what is a difference, kind of interesting, is that when we go a little bit past the noise level, all of a sudden the chord gets a discontinuity in here where the response goes to plus or minus infinity, relatively speaking infinity, whereas the topping is just flat and just gone to noise floor and it just settles there. And if I just show you that chord response by itself so you can easily see it, this is the first one, but if I zoom out, you can see that it keeps repeating. And so that's not a good thing. I don't know why you would want this. Now, the amplitude of this is so small as to not make an audible impact because, again, it's sort of one of these little ticks over here that you can barely see. But, you know, objectively, the company talks about zooming in minus 300 dB and looking inside, and there are little bits that are better and nicer. Well, I don't see that, and I see basically what looks like a computational flaw, windowing flaw, some kind of flaw. Usually you don't get this in FIR filters, so I don't know why it's there, and then it's repeating. You can also see a drift in here where the levels are shifting down to -2 microvolts. So that's not good either. If you look over here, the topping stays, you know, right at 0 over here. Now, I'm not going to say any of this is audible at all. You can't interpret an impulse response with a human eye and talk about it. All this talk about, you know, smearing, all that stuff is all nonsense. It's not how the brain works at this kind of resolution. But if it is, we certainly don't have objective proof in favor of a chord. We actually have this measurement against it. This is why it's good to ask the company for measurement. When they say, oh, our impulse response is great and, you know, the filter is perfect and everything, is like, okay, don't just say those things. Demonstrate it, show it, make a simple comparison, and then we can see. I don't know why the company doesn't show it, whether they don't have the data or if they have it, doesn't look good, I don't know. But here it is, you know, you have the timing information. Let's switch to the headphone amplifier. The noise performance is really poor in there. I'm making measurements at 50 millivolts, which is what you need for a very sensitive IEM and or headphone. And we only get about 78 dB average between the two. 78 dB if you plot it against, you know, 100 some other headphone amps that I've tested, lands well below average. This is where it's sitting. And the state of the art is out here around 95 dB or so. So it is way, way down there. So I'd say on sensitive IEMs, it's gonna hiss and buzz or whatever noise, background noise that it has. So it's not suitable for that. And it should be at this price. There's plenty of power available. This is using the front 1/4 inch plug. If you use a high gain, you get about 230 milliwatts, and which is a lot. I like to see at least 100 milliwatts. Excuse me. And selecting low gain also causes clipping still, which is strange to me. The whole point of low gain is that you're not driving the amplifier for it to clip. So this is somehow still clipping, which is strange. But anyway, performance, noise per floor, you can see still higher than the reference that I have. Is cheaper topping DAC. That's now obsolete. Does better as far as noise, but the TT2 has more power than it. Switching to the other, that was 300 ohm load. This is 32 ohm load, and we see similar kind of picture where there's more power available, about almost 2 watts, but the noise is still not competitive on this thing. And if I change the load impedance all the way down to 12 ohms, we see that using 1/4 inch output in the front, basically is able to maintain the same voltage and keep increasing power. Every time you go lower impedance, there's enough current in there to keep doubling. And this is pretty unusual and very good from point of view of driving low impedance headphones on this. There is a funky feature in this thing that's only available in this. I've never seen it elsewhere, and that you can use the XLR output in the back as also a headphone output or even a speaker output, the company says. You, of course, have to make your own custom cable that goes from there to your headphones. Only 3 pin, and there's two connectors that have to drive one headphone, so you have to build that yourself or buy one. I don't know if there's a commercial one, but not a big deal. You can do that. So I went ahead and measured it. I didn't have the right adapter, and I could only measure the 300 ohm. And indeed, the power goes through the roof, quadruples almost, using the differential outputs in the back. So we now get almost 1 watt at 300 ohms. That's a ton of power. So even a 600 ohm impedance headphone or even higher, even if it's insensitive, is no match for this thing if you use the rear connectors. At the same time, be careful. It can blow up those headphones, and it can also blow up your ears. As much as I'm a fan of playing loud and everything, you get to pretty dangerous levels when you have so much voltage and current coming out of the thing. Basically, it's a mini power amplifier sitting inside the thing. I did some listening tests. The company loves the Dan Clark Stealth headphone, which I also have. It's a $4,000 headphone, quite expensive, but it's got one of the lowest distortions I've ever measured, and it's very neutral, so you don't need any DSP to correct it. And I listened to a range of reference tracks that I listen to all the time. I've listened to these tracks probably 1,000 times, and I could detect no difference in with this DAC versus hundreds of other DACs that I've listened to. Same resolution, same dynamics, same everything, and it sounds excellent. These are great tracks that I use for testing, and all of them sounded perfect, but no more perfect than any other DAC that I've tested. You know, it's just no magic in there and any of this filtering and so forth that the company claims. With Dan Clark Stealth headphone, this is a tough headphone to drive, and I could get it quite loud, but if I went a little bit further past that, it would get distorted, which almost every amp does. So, but this was using the quarter-inch in front. If I'd used the rear one, it probably could drive it without getting distorted. But, you know, plenty powerful for that headphone, you know, for everyday use. With the HT650 Sennheiser high impedance headphone, it's more sensitive, and there was just tremendous amount of dynamics and power available. So just like any other high performance headphone amplifier, it produced great sound. So the upshot of this thing is that you have excellent performance over here. If I had never tested any other DAC and headphone amp, this was the first one that I was testing, I would say, wow, this is great. But the world has moved on since this company, Chord, put out this DAC. There's been a race in who can get the lowest noise, maximum power, least amount of distortion in the market, and the incredibly budget prices. You know, $600 or $700 expensive in that domain, let alone $6,000. So the world has moved on, and they have left this product behind. You can get all of this performance except with a filter in 10% of the price of this. And frankly, they look better in my opinion. They're easier to use than this hodgepodge of design features and buttons and globes and lights and just quirkiness. And by the way, this doesn't look expensive to me either. I mean, if you had a family member come look at it and say, what'd you buy for $6,000? It'd be like, you bought this? It just doesn't look fancy. And then, by the way, I will pay thousands of dollars for something that looks really fancy and performs. I have no problem buying $5,000 or $10,000 DAC if it came in a gorgeous cabinet and, you know, proper piece of hi-fi. But anyway, beyond that, you're basically paying $6,000 for that filter. So you got to decide whether, you know, it's worth it to just have that filter. It has no audible impact that I can detect on that. So I can't recommend this thing for you to buy. But if you own it, nothing about this review says it's a terrible device. It's an extremely high performance device. Its noise and distortion, if you're using it with less sensitive devices, is transparent, is state of the art. It isn't state of the art, it's transparent to your hearing, so it's going to play the source material as good as your source is, and your limiting factor would be your headphones that you're hooking up to it. But if you don't own one, rushing out to buy this thing, it just makes no sense to me for many, many reasons that I've talked about. You're just better off buying a desktop DACs. You can get this combo of features and most of that performance for a couple $100, $200 or $300, and then you can go state of the art, $600, $700, and you're done. And you know, should it break or something, you don't have to deal with servicing something like this. And by the way, this thing runs warm and on this thing, so I don't know what the reliability is going to be longer term on this. Okay, so with this, we're done testing Chord UK products for a while at least. Hope you got something out of it. See you in a future video. Bye-bye.